Before we can begin the learning process, we need some data that represents the things we are trying to learn. We will organize our data as a table or a matrix where each row represents one piece of data and each column represents something about that one piece of data. I'm going to do this in Excel, but you can do this in any sort of table you want, because ultimately we're going to put this into Python anyways. So let's build some data for our color, shape, size pieces. I'll create a table where each row is one piece. I'll give the pieces names so that we can remember which piece is which. Next, I need to make one column for each property or feature of the piece that is representative of it. For example, I might want to record the color. I will say that 1 means red, 2 means green, and 3 means blue. So I'll create a column for the color, and I'll fill it in. 1 means red, 2 means green, and 3 means blue. Now, I have no data to represent the shape yet, so I'll create a column that's called sides, and I'll record the number of sides that each piece has. So a square has 4 sides, a triangle has 3, and a circle has 1 side. Finally, each piece also has a size. I'll refer to the big size as 2 and the little size as 1. Now, to start with machine learning algorithms, it will help us to start by learning how to picture data as points on a plot, where each dimension of the plot represents one feature or characteristic of the data. So I am going to take this data and enter it into Python. Let's start by importing the different packages that we'll need. This third package is a new one that we haven't used yet. It will allow us to plot things in 3 dimensions. We'll create a new figure. Then set up the axes for 3-dimensional plotting. Now we need to take the data that we created in our table and enter it into Python. We'll do this by creating 3 separate arrays, one for color, one for the sides, and one for the size. So in the color field, I'm going to list from the top to the bottom the color value of each data point that we put in our table. I'll do the same thing with the number of sides. And then the size. Now, let's plot all of this data. We'll do it by creating a scatter plot. We'll also want to label the axes so that we remember what each axis represents. Now, let's test this. You should get a plot that looks something like this. You can rotate the plot to look at it from different angles by left-clicking and dragging. Each one of these data points represents one of the little colored pieces that we entered into our data. Each piece has a different combination of values for sides, size, and color. Now, here's how k-means clustering works. This is an algorithm that is used to find natural clusters or groupings within the data. Right now, it doesn't look like we have any clusters in the data because we've plotted all of our data, and there are many different natural clusters represented in the pieces that our data was drawn from. But k-means clustering might still work for us because this method allows us to start it off with some seed locations where it will look for groupings. Here's how it works. We start by specifying 2 seed locations. Then the algorithm will check the distance between every data point in our list and each of the 2 seed locations. Every data point that is closer to seed 1 than it is to seed 2 will be placed in a list for seed 1, and every point that is closer to seed 2 will be placed in a list for seed 2. Then the algorithm will calculate the center location of all of the points in each of the 2 lists. Those center points become the new seed points, and the whole thing repeats. Every point that is closer to seed 1 gets placed in the seed 1 list, and every point that is closer to seed 2 gets placed in the seed 2 list, and the new center is calculated again. After the center point is no longer moving, we stop and look at the 2 lists. Those 2 lists tell us which points, or colored pieces, the algorithm thinks belongs in each of the 2 clusters or categories. Let's try it. Close your figure window and we're going to add some code. The first thing we need to add are the 2 seed locations that we'll start with. I'm going to pick one of the colored pieces as my seed, both for seed 1 and for seed 2. Note that this doesn't have to be the case. Your seed could be a data point that isn't in your database anywhere, but for now I'm going to pick one of the data points that is in the database. So if I set seed 1 to 1, 4, 2, then seed 1 will be the big red square. For seed 2, I'm going to start with setting seed 2 to be the little blue circle. So that would be 3, 1, 1 for the little blue circle. Now I'm going to have the code print out what each of these seeds is, because as we run the algorithm, the seed location is going to change. So if I always print out the seed location, that will help me keep track of whether or not the seed has changed. The first step in the k-means algorithm is to calculate the distance between each point and each of the two seeds. I'll calculate the distance between one of our colored shape points, we'll call this point I, and seed number 1. So I'll take the color value of point I, subtract the color value of seed 1, and then square it. Then I'll take the difference between the sides value of this point and the number of sides value of seed 1, square it, now we also need distance from seed 2, so I'll copy this line and paste it here, and then we'll change this to distance from seed 2. And then these have to become seed 2. Now, if the distance from seed 1 is less than the distance from seed 2, we want to add this point to a list that means that this point belongs to seed 1. I'm going to keep track of each of the features of the point separately. So we'll do seed 1 members. These are points that belong to seed 1. The color value, so we will append on to the seed 1 member's color vector the color I value. Now, since I'm appending something on to this array every time, I need to make sure that I've already created this variable so there's something to append onto. So up here, let's do seed 1 members color is equal to an empty array. Now I want to do this same thing not only for color but also for the number of sides and the size. So I'll copy this line and paste it twice, and then in place of color I'll do sides and size. So just like I created the variable color up here, I need to also create variables for seed 1, for sides, and for size. Okay, then else, that is, if distance from seed 1 is not less than the distance from seed 2, in this case, I want to save each of these variables in seed 2. in the seed 2 members. So I'll copy all 3 of those lines and paste them here. And now the only thing I want to change is instead of seed 1, I want this to be for seed 2. And I need to change it 2 places. There we go. And of course, just like we created the seed 1 variables up here, we need to also create the seed 2 variables. Okay, right now I'm only checking this distance for 1 point, a point I've called I. I want to make sure and check this distance for every point, each little colored shaped piece that I have. So I'm going to start out by setting I equal to 0, then I'll do while I is less than. I want to do this calculation for every color shaped piece. So I'll do np.prod color.shape. So this is going to check how many elements are in the color array, which we already created up here. And we'll keep doing this as long as I is less than the number of elements inside color. So I'm going to take all of these things here and indent them so that they're all inside this while loop. And then I'll also increment I at the end here. Now we have code here that loops through every one of the data points in our database, calculates the distance of each data point from seed 1 and seed 2, and then sorts each data point either into a list of data points that belong to seed 1 or data points that belong to seed 2. In our k-means learning algorithm, the next step is to calculate a new seed 1 and seed 2 as the mean value of all of the data points that belong to seed 1 and all of the data points that belong to seed 2. Before we write in that code, let's change our plotting here to test what we just finished. Down here, let's comment out our current scatter plotting, and let's write a couple new lines. Let's plot all of the data points that belong to seed 1 and let's plot all of these points in a blue color. Then copy this plot line, paste it, and change seed 1 to seed 2. These points we're going to plot in a red color. So in other words, all of the data points which the robot thinks belong to group 1 will be plotted in blue, and all of the data points which the robot thinks belong to group 2 will be plotted in red. So let's run this and see what it looks like. So it looks like I made an error up here. I put a semicolon instead of a colon. Make sure you have a colon here, and then run your code. You should get a plot that looks like this. Now remember, the blue points are the ones which have been sorted as category 1, and the red points are the points that have been sorted as category 2. Now before we think about how to interpret this plot, let's finish our code. Let's add in the part of the algorithm where we calculate a new seed location. So here's how we do that. We'll make a new seed 1, and we'll define this seed 1 as the mean value of seed 1 members color. So we're going to take the mean color value of all of the data points which have been sorted as being part of group 1. Then the y value of this new seed will be the mean of seed 1 members' number of sides, and lastly we have to do the size. We have to do the same thing for calculating a new seed 2. So copy this line and then paste it, and this will be new seed 2. So we have to change seed 1 to seed 2 in the x, y, and z values. After we calculate a new seed 1 and seed 2, we need to repeat what we just did. Calculate the distance from seed 1 of all of the data points, calculate the distance from seed 2 of all of the data points, and then sort them according to their distance from seed 1 and seed 2. So instead of rewriting all of this code that we already have, I'm just going to put the whole thing inside its own loop. Now this seed 1 and seed 2 shouldn't be inside the while loop because we don't want to calculate a new seed 1 and seed 2 until all of the data points have been sorted. So I'm going to delete this here so that this is not, there we go, in the while loop. Now let's select all of these lines all the way up to here, and then I'm going to tab them so that I can make this, all of this, inside its own loop. I'll create a new variable called runs. This will be the number of times we're going to go through this loop. So I'll start out with runs equal to 0, and then I'll do while runs is less than, for now let's just do 3 runs, colon. Now take these 2 print lines and cut them. I'd like the program to print out the seed locations every time it calculates a new seed location. So we'll put these lines here, and then we'll increment runs, and that's it. After the 3 runs, we will plot. So let's run the code again. You should get a plot that looks like this, and you may notice that the points have been sorted differently than they were sorted before. We need to check to see whether we made enough runs. So if you look at your output window, you should see that it's printed out the seed 1 and seed 2 every time. So seed 1 and seed 2 were this after the first time through the loop, and then they changed to become this. And then the next time through the loop, they did not change anymore. And that's an indication to us that we looped through this whole algorithm enough times. And we can reliably say that these are the groupings that the algorithm will come up with no matter how many times we loop through this algorithm. So let's think through the meaning of this plot that we have here. Remember, the blue points are the points that are belonging to seed 1, and the red points are the ones that belong to seed 2 or group 2. Let's go back up here and remember that we set seed 1 as the big red square, and we set seed 2 as the little blue circle. So the big red square has had all of these blue points sorted into its category. Which are these points? Well, we can figure out by looking at the location of each data point. So this point right here has a size of 2, so it's big. It has 4 sides, so it's a square. and the color is 3. So it's the big blue square. This code has grouped the big blue square together with the big red square in the same group. What about this point over here? It has one side, so it's a circle. It's big because its size is 2, and its color is 3. So this is the big blue circle. The code has grouped the big blue circle together with the little blue circle instead of the big red square. Now, what would happen if we chose a different seed to begin with? Up here, I'm going to copy this seed 2 point, and let's make this seed 2 be the little blue square instead of the little blue circle. Now, let's run this code again. Here's the plot, and you can see that this grouping is different. In fact, it seems to have grouped along the diagonal here. When the color is 2, these are green objects. And what we're looking at in this dimension is size. So these points up here are large green objects, and these points down here are small green objects. So in this grouping, the large green objects have been placed together with the big red square, while the small green objects have been placed together with the small blue square. In other words, our algorithm has decided that large objects are more similar to the big red square than they are to the little blue square, and little objects are more similar to the little blue square than they are to the big red square. I want you to try one more set of seed 1 and seed 2 and run the code, and then make a list showing which of the objects were grouped together with your seed 1 and your seed 2. So what I want you to put in your output for today's lab portion is, what did you pick for seed 1 and seed 2, and what was grouped together with group 1, seed 1, and what was grouped together with group 2, seed 2. Can you explain why the grouping came out the way it did?